This is the second video for March 31st or April 3rd, depending on what A or B day you are. And I told you on the previous video that I would post the solutions for these 6. Here are those solutions, going from the exponential to the logarithmic. That's how we would write this. Exponential to logarithmic. Here's how we would write that equation, and logarithmic to exponential. Again, if we have ln, it's understood that our base is e. So we have e raised to the 5th equals 5x. And then here, I'm not going to go over these, but here, these would be your three, the valuation of those three functions. I'm going to let you try to figure that out if you didn't get those. If you have questions, if you have questions about those three, please let me know. Ask me in class, outside of class, and I'd be glad to help you out with that. But let's go ahead and flip to the back side and look at how these graphs behave. Now, if you got this offline, you didn't have these 2 points. But we have 2 key points here, 1, 0 and 2, 1, 1, 0 and 10, 1. Here we have log to the base 2 of x. Hopefully we can notice here that our base, if there is no base, our base is 10. So this would be log to the base 10 of x. And what we did in class is, if you've been coming to class and seeing how we do this, no different than this week. What we did is we looked at the graphs of the functions, saw what they were doing, like here, and then we talked about what do we have in common. And people noticed a lot of different things. One thing that people noticed is these functions, as we continue in this direction, they're going to get really, really close to the y-axis. Same thing here. It looks like it's touching, but it's actually not. It's getting really, really close to the y-axis, but it never touches. So both of these functions, right? These are just 2 of our log, what I'm going to call parent functions. Our log parent functions. And these kind of represent the entire family of the parent functions. So we can notice some things about these 2, notice what's the same, make some generalities, and be able to apply that to other functions. But here, these 2, they never touch y-axis. And in class we talked about, well, hopefully there's a term that we could use to help kind of summarize what's happening there. Hopefully you know that term, and that term will be, it's an asymptote. Here we have a vertical asymptote. So same thing as last time. I'm going to put a star next to anything that's like super key. We have a vertical asymptote at this piece. We call that x equals 0. Everywhere on the y-axis, our x value would be 0. So we have a vertical asymptote at x equals 0. Other people notice, hey, they both go through 1, 0. So we do have an x-intercept at 1, 0. All of our parent functions will go through that point. The reason why, let's say we have log to the base a of x. That's our function. Well, if I plug in 1, this is saying a raised to what power gives me 1. What we talked about last class, anything raised to the 0 power gives us 1. So that's why it's 1, 0. So all of our functions, regardless of the base, will go through 1, 0. Another thing that we noticed here is that our base is 2. It went through 2, 1. Our base is 10. Here, it goes through 10, 1. And that's going to be true in general, that if our base is a, it's going to go through a, 1. Now, I do want to spend some time explaining that. If I have log base a of a, I'm basically taking this function instead of x, I'm plugging in a. Anytime you have the same base and the same base is happening, the base is what's being plugged into our function. Again, we need to be thinking exponents. We need to be thinking a raised to an n power gives us a. That's what this is saying. We're trying to evaluate there, right? Well, a raised to what power gives us a? 1, the first power. A raised to the first power gives us a. So if we plug a into our function, then what that's telling us is that the value that we get out is always going to be 1. So it's going to go through that point. We also talked about domain. Of course we talked about domain. Domain and range. Let's start with domain. People noticed, so we're usually like, domain, negative infinity to infinity. Write it down, boom, moving on. But we have to be careful here, right? Domain, we're talking about how far left it goes, how far right it goes. So in general, most of our functions, they go to the left forever. So we can start with negative infinity. But here, hopefully we can notice here, as this function keeps going left, the furthest left it's going to go is 0. Here, the furthest left this function is going to go is 0. It's never going to go past our y-axis. It's never going to go into the negative direction. So our domain here is actually 0, and then as we keep going to the right, it's going to go to the right forever. It's going to, you know, if you want arrows here, that's fine. That might be a good thing. It's going to go to the right forever. So our domain is 0 to infinity. I didn't put a bracket or parentheses here because we need to talk about that. Here is, will it ever touch 0? Will it ever touch 0? Well, due to this asymptote that we talked about, it actually won't. So we put a parentheses. It's going to get really close to 0, but never touch. In our range, if we think about what's happened with the lowest value that it's going to take all the way to the highest value, up and down. Here, this arrow is going to go down forever, so it's going to go towards negative infinity. As we go this direction, it's going to go out. It is going out, but we don't have a horizontal asymptote, which means as this function is going out, it's also increasing. So this function, as we continue to go out, it's also going to go up. And so our range, it will go towards infinity as we continue going in this direction. So these are the 4 things that we're really going to look at with these logarithmic functions. We're going to talk about these key features when we graph our logarithmic functions, transform them, and see what's happening. Now, in each class, we did talk about end behavior. Most likely will not ask about end behavior on an assessment. For log functions, exponential, sure, but for log functions, maybe not. But we still need to look at it. If we look at as x goes forever in the right-hand direction, and this applies for both functions because they behave similarly. As x goes forever in the right-hand direction, our x values are going towards infinity. Now, as we continue going towards infinity on the x-axis, what is our function doing? Well, our function, we just said here, based on in our conversation about the range, that it's going to continue to expand, but it's also going to go up. And so our function, as x continues to go in the right-hand direction, our function continues to increase, so it will go towards infinity. Now, when we talked about left-hand behavior, usually we say as x goes towards negative infinity. As x goes to negative infinity. But a lot of students notice, hey, our x values, we actually can't go to negative infinity. Here, the function doesn't cross the y-axis. And that's also true based off our domain. The furthest left it's going to go is 0. So if we want to talk about left-hand behavior for our log parent functions, what we need to talk about is as x goes towards 0. As x is getting closer to 0, because it's never going to cross here. Then as x gets closer to 0, as we continue moving to the left here, what's our function doing? Well, as we continue moving left, our function is going to get really close to 0, but it's also going to continue in decreasing. So our function, we say, goes towards negative infinity. So for these functions, end behavior looks a little bit different, but we can still, I mean, it's good concepts, especially if you're planning on taking, well, even if you're not planning on taking calculus, but you have to, at one point or another, you're going to need to understand how functions behave, so it's a good idea to talk about this and think conceptually about what's happening to these functions. In general, though, I'm going to ask for these 4, well, I could ask for x-intercept, but mainly these 3 things. End behavior would be a bonus. But this is how our logarithmic parent functions behave, how they behave our parent functions. On the next video, we're going to see how transformations change these behaviors and how we can apply transformations to our logarithmic functions.